Good morning to all of you MSc Physics second year student. So welcome to again lecture series on our subject which is energy study physics first, and we want to continue our third chapter which is basic of the heat transfer. And in this lecture we want to continue the point which is considered as the introduction of measurements and the units. And summary of the last lecture, we have to see her idea, the small concept which is about how to write the dimension of the quantity and how to derive the units which is based on this dimension. And last lecture we have already see that one of the example, for example the force is given, and that force which is nothing but the mass into acceleration, and acceleration which is nothing but the time rate of change of velocity with respect to time, and depends on this concept. So that dimension which is given here m power 1, l power 1, t power minus 2, and depends upon this we have to derive here the units of this quantity which is kg meter per second square. So that type of, so here in this lecture we have to see that some quantity, some needful quantity or helpful quantity that derive or involve some physical dimension and units of this quantity. Now first quantity is here, so we have to consider that is quantity which is nothing but the length. Okay, so that is the first quantity, and dimension which is considered as the simply L. Actually dimension which is considered in terms of the L, M and T, or which is considered as MLT. So here that length which is only depends upon the distance, not depends upon the mass and time. So that's why dimension is L, and SI unit of this length which is considered as the meter, and symbol which is considered as the small m. Now next quantity which is considered as the mass, that dimension which is considered as that depends upon the value of the mass of particular quantity or substance, and that mass, that SI unit which is considered as the mass which is kilogram, and which is denoted by the kg. Next quantity which is considered here the time, third quantity which is given as here time, and dimension of this quantity which is considered as the t, and SI unit which is considered as the second. Okay, and that is denoted by the small s. So this describe three main quantity, and depends upon this quantity other physical quantity dimension which is described here. So now after that we want to calculate here the velocity, and that velocity which is nothing but, okay, velocity, okay, and if we see the dimension and basic unit of velocity, so that velocity which is nothing but the change in time. Okay, so that change in distance, with respect to time. So that is the quantity which is considered as the, that is quantity which is described as the velocity. And if we see that change in distance divided by time, so that dimension which is given as here m power 0, that is there is no mass, that change in distance that is l power 1, and time which is nothing but the t power minus 1. Okay, that t power minus 1. So this is the dimension of this velocity, and if we see that the SI unit of velocity which is nothing but SI unit of velocity which is nothing but that length unit which is considered as the meter. Okay, and this t inverse, that unit which is considered as the second, so that is considered as the meter per second, or which is simply say that meter per second, that is right in terms of this fashion. So that velocity, that dimension which is given as here, that m power 0, l power 1 and t power minus 1. So this is the dimension of the velocity, and unit which is nothing but that meter per second, or which is simply say that right in terms of this meter per second. Now next useful quantity which is nothing but the acceleration. And that if we calculate the dimension of the acceleration, which is in terms of the given quantity, if we see here that acceleration is nothing but acceleration which is in terms of nothing but that is dv divided by dt. Okay, so that is time rate of change of, or which is rate of change of velocity with respect to time, or velocity which is nothing but the rate of change of distance or displacement with respect to time. So that is considered in both idea. So that dimension which is nothing but that L upon that twice of times is there. Okay, so that this formula which is nothing but d by dt into velocity which is nothing but dx divided by dt. Okay, so that depends upon this term of twice time of this time. So that dimension which is nothing but L upon t square, or that dimension which is nothing but m power 0, after that L power 1 and t power minus 2. Okay, so this is the dimension of the acceleration. And if we see that SI unit of acceleration, and that SI unit of acceleration which is nothing but that m power 0, L power 1 and t power minus 2. So this is dimension, and depends upon this, that depends upon the that length unit which is considered as the meter, and time unit which is considered as the second. So that unit which is nothing but meter per second square, and that is the directly nothing but that meter per second square, that is the unit of the acceleration. So we want to write here that dimension which is nothing but acceleration is m power 0, L power 1 and t power minus 2, and unit which is nothing but that the meter per second square, or directly written in terms of meter per second square. So due to this idea, so we have to calculate the dimension and unit of the physical quantity which is given here. Now next physical quantity which is given as here, that force. So that is the fifth number quantity, that force. And if we see that force is equal to mass into acceleration. Okay, and if we see that here, so if we want to calculate the dimension of this, so that mass dimension is m, and this acceleration dimension which is nothing but the m power 0, l power 1, t power minus 2. So that force dimension which is nothing but here, so that m power 1, l power 1 and t power minus 2. So this is the dimension of the force, and if we write the SI unit depends upon this dimension, so which is given as, if we see that m is there, so that is mass is there, so that mass dimension which is nothing but the what is m power 1. After that if we see here, here L is given, so mass is the kg, L in terms of the meter or T in terms of the second square, so that unit which is given as kilogram into meter per second square or per second square, so that is in terms of kg meter per second square. So that depends upon this dimension, we have to derive the unit is here. So that fifth number quantity which is given as the force, dimension of force which is given here, that m power 1, l power 1 and t power minus 2, so this is the dimension of this quantity, and unit of this quantity which is nothing but the kg into meter per second square. So this is the unit of the quantity which is given as the force. Now next quantity which is given as here, the work. If we see that work and energy both are the, or both is the same quantity or same dimension, but small different idea is there. So now we want to write here the sixth quantity which is given as the work. Okay, and we have to know that idea, so that work which is nothing but the force into distance. Okay, that work which is nothing but the force into distance. Okay, and if we see that the force dimension which is given by here, m1 l1 t power minus 2, so the right here dimension m1 l1 t power minus 2 and into that distance dimension which is given as l power 1, so that dimension of work which is nothing but as given here, so that is given as m power 1, l power 2 and t power minus 2. Okay, so this is the dimension of work, and if we want to write the SI unit, so depends upon this, so that is mass is given, so that is kilogram. Okay, if we see that dimension unit of that length, and length unit is meter, hence is length square, that is means by the meter square, so that's why we have to say here, so that the meter square per second square, so that SI unit which is given as the kg meter square per second square. So that with the help of this dimension, work dimension, so we have to derive here the SI unit of the work, so that right in terms of that work is equal to force into distance, and that dimension which is nothing but here, so that m power 1 l square and t power minus 2, and that SI unit which is nothing but the kg dot meter square per second square. So this is the quantity which is dimension, particular dimension, and SI unit is there. Now next quantity which is given as the energy, and already we have to see here that quantity, energy and work, that unit direction, dimension and units of both quantity, work and energy is same. So that's why we want to write here the m power 1 L square T power minus 2, and that right unit which is in terms of the kg dot meter square per second square. Now next quantity we want to see here the power, and that power which is nothing but work per time. Next quantity which is given by the power. Okay, and if we see that power which is nothing but work per time, work per time. So if we write here that power, what is this power, and this power which is equal to the work per time, work per time. Okay, and if we see here that unit dimension of this work which is nothing but the m power 1 L square T power minus 2. Okay, T power minus 2, and again one dimension which is given by per time, so that dimension which is given as the T power minus 1. So that total dimension of the work, that power which is given as m power 1 L square T power minus 3, and if we see that the SI unit of this power, SI unit of this power which is given as here, so SI unit, if we see that the force dimension, okay, where force dimension, that m power 1 L power 1 T power minus 2, so that is given as the kg into meter per second square, and that kg into meter per second square, so that nothing but the unit which is given as the Newton, which is given as the Newton, and that work and energy unit which is given as the joule, and that symbol which is given as the capital J, or this symbol which is also given as the capital J for the joule. If we write, so that the SI unit, so that m power 1 L square T power minus 3, so that unit which is given as here kg meter square, kg into meter square per second cube, per second cube. So that we want to write dimension here, so that is given as the m power 1 L square T power minus 3, and that SI unit which is nothing but the kg meter square per second cube, or this unit which is nothing but the watt, or which is denoted by the capital W. So these are the different physical quantity, these are the different physical quantity. So that is we have to denoted or describe, which is the help of the simply that dimension which is considered as the length, mass and time, that is given by L, M and T. Okay, so that this is the idea about the basic units and dimension of the physical quantity. Now we want to see the next point which is given as here, so that is the main point of this chapter, or which is considered as the main concept. So that concept which is given as the heat and thermodynamics, so that we have to write here the initial of this, or point which is given as the heat and thermodynamics. Okay, so this is the actual point of this chapter. So first of all, we have to know that, or we want to study or understand the concept of the thermal energy. What is mean by the thermal energy? So first of all, what is mean by thermal energy, or which is also called heat energy, that is produced when rise in temperature. When rise is temperature causes atoms and molecule to move faster and collide with each other in a substance, or which is considered that the energy that comes from the temperature of the heated substance, that energy which is comes from the temperature of the heated substance is called as the thermal energy. So we want to write here the definition that thermal energy is produced. Okay. uh, Now first point is the basic concept, that is known as what is mean by the thermal energy. So that thermal energy, and that thermal energy which is nothing but the thermal energy is produced thermal energy, and it is also called heat energy. Also called heat energy. Is produced. Thermal energy is produced when a rise in temperature. When a rise in temperature. Rise in temperature causes atoms and molecule. Causes atoms and molecules to move faster. To move faster and collide with each other. Okay, so that is known as the thermal energy. Once again see that thermal energy which is nothing but that thermal energy which is also called the heat energy, and that heat energy which is produced when a rise in temperature. So that temperature which is increased due to the cause of that atoms and molecules, or which is considered as the ions, which is moved the fastly and collide with each other, and that atoms and molecule which are collide with each other due to that what, so that rise in temperature of the substance or the molecule, and that energy, and that produce the energy, in that energy which is nothing but the thermal energy. Or second definition which is considered as that substitute for this definition, so that energy that comes from the energy that comes the energy that comes from the temperature of the temperature of the heated substance is called thermal energy. The heated substance is called thermal energy. Is called thermal energy. So this is the idea about the thermal energy. So that is mean by the rise in temperature in a substance or a molecule or atom. So that energy which is nothing but the thermal energy. And next concept which is considered as the heat, that thermal energy which determines the physical state, which is considered as the temperature, or which is considered as body and work which is obtained from the body through the transformation of the energy. So that is nothing but the heat. So in this lecture or in this concept of the heat and thermodynamics, so that we have already see the point of the thermal energy. Now we want to that point to analyze or to understand, which is considered as the what is mean by the heat, what is mean by enthalpy, what is mean by entropy, what is mean by the equations, what is mean by temperature, or what is mean by the internal energy, Gibbs free energy, Helmholtz energy, enthalpy, whatever the concept, and what is mean by the specific heat capacity. So that all point we have to understanding in this chapter or in this concept. So next lecture that will that point we have to cover in the next lecture. So thanking of you.